Cool. Here's the second part of 12.1 screencast for intermediate algebra. So we're going to start with trig functions. They can be used to find the missing side length and angle measures of right triangles. But first we have to determine the unknown quantity, whether it's a side or an angle. So we need to zero in whether we're solving for a side or an angle. So guess what? Example 7 is to find a missing side. Find the missing value of x. Round to nearest tenth if necessary. Okay, so I have this angle. All right, I have this angle 53 degrees. Yeah, I'm probably going to use SOHCAHTOA, but I need to label which side is my adjacent, which one's my hypotenuse, which one's my opposite. So x is going to be my hypotenuse. 15 is my opposite side. And I don't have an adjacent. Like, where is this? I don't know. I don't know the length of it. But I want to solve for the hypotenuse. So which trig function uses hypotenuse and opposite? So let's think. SOHCAHTOA. Which one depends on hypotenuse and opposite? Sine. Sine depends on opposite and hypotenuse. So if I would write this out, if I would write sine of, what's my angle? 53 degrees is equal to opposite 15 over hypotenuse, which is x. Okay, so I'm trying to solve for x. Sorry, what? You do sine, yeah, 53, it's this in button. But I want to solve for x first. I want to get x by itself before I plug in any numbers.
So do times by x.
Multiply both sides by x. Okay, so now I have x times sine of 53 degrees is equal to 15. I really want to get x by itself. I want to solve for x. I'm trying to find the side length. How do I get x by itself? Divide both sides by sine of 53 degrees. So sine is like an operation. It's kind of like a plus sign. Like I'm doing an operation. I'm doing a function to my 53 degrees. So I'm dividing by sine 53, so that's just going to be some number. All right, sine 53, sine 53. So I have x is equal to 15 over sine of 53 degrees. Okay, so if you plug that into your calculator, what do you get? So I want you guys to practice plugging into your calculator. Do you want me to show you how to plug it in?
That's the name. Wait.
Okay.
Is that your answer?
No, I want you to plug it in so I have an answer. I plug in 15 divided by sine 53.
I can do that.
Okay. Okay. Do you have it in degrees or radians?
What?
Do you have it in degree mode? I think you're right. Yeah, 18.8, yeah.
Whatever you put it in, I don't know.
Does it say DEG at the top right or RAD? So it's degrees.
Yeah, how do you do this?
Okay. So I'm going to go to my home. Okay. Calculate. Ready? See where it says calculate?
Yeah,
Enter. And now I want to do 15, so 1, 5, divided by sine of 53. So you go where it says trig, click on trig.
Where does it say trig?
The top left corner.
Oh, trig.
Yep, click trig, go over to where it says sine, right? So you'll like click enter on sine, and then inside put 53. Do you notice like where it says DEG up at the top right corner? You need it to be in degree because I have 53 degrees, and then push enter, and guess what? 18.78, but we're supposed to round to the nearest tenth, so what should I write?
0.8.
18.8, okay, so this is 18.8, it's not degrees, it's the side length, right? So it's just 18.8.
Can we please not do rounding?
We are doing
From
rounding.
the 10th?
It says to the 10th, and that's what we're doing. All right, part B.
Just shoot me.
That's always
Put me on
That's
my
it. Just we had just said find x.
like a buffalo.
All right, so let's go on to this one. I have my angle. Let's go ahead. Let's label the sides. So x here is my
A.
adjacent, right? 9 is my
Oh.
opposite. Yep, and I don't know my hypotenuse. Like it doesn't tell me. So which trig function should I use if I have the adjacent and the opposite sides?
You could use C or T.
Tan.
What's the difference? Oh,
Because
you don't have H.
I don't have h.
Yeah.
Okay, so I'm going to say tangent of 21 degrees is equal to opposite 9 over adjacent x. I need to get
Multiply by x,
multiplied by x on both sides.
and then you divide by tan the 21 degrees.
Divide by tan 21 on both sides. Good. So x is equal to 9 divided by tangent of 21 degrees. So 9 divided by tan 21. 9 divided by, go to trig, push tan, 21. I get 23.4458. What is this rounded to the nearest tenth? 23.4. Good. So this is 23.4. Awesome. So that was solving for a missing side length. What if I want to find the missing angle? So there's a thing called the inverse trig function. So if I had like, for example, if I had like x squared is equal to 16, how do I get rid of the square? How do I get rid of a square? You do the square root, because that's the inverse operation. That's the inverse operation. The square root and the square cancel each other out.
So it's x equals 2.
So these are the inverse operations. So if I want to find, I'm just going to go to the example. If I want to find which angle am I at when sine equals 1/2, I'm going to do sine inverse to both sides.
Wow.
That gets rid of the sine function. So by doing sine inverse, guess what? The sine inverse and sine, they will cancel out, and that leaves me x is equal to sine inverse of 1/2. So remember how like square root and square are opposite? Inverse? Sine inverse and sine are opposite. They will like cancel each other out.
Negative 1.
To the -1, that means
Negative 1
inverse.
times x is negative x. Right?
It's not -1 times x.
Is there any other way to do
Sine
that?
to -1 does not mean 1 over sine x. It literally means the inverse function. What this means is it gives you the angle. So whenever you have an inverse like sine to -1, what this secretly says is like, what angle am I at when
Wait, so what's the answer?
when sine equals whatever number it was.
What's the answer?
We haven't plugged it in yet.
But there are no ways.
So x equals sine inverse of 1/2. So if I go to my calculator, I push trig, and notice how there is sine to the -1, the sine inverse.
I don't even understand how you got the x equals sine -1 in parentheses 1/2. I have no idea.
Okay, so I take the inverse on both sides. It's just like up here when I would square root both sides to get rid of the square.
No, I understand.
I take sine inverse on both sides to get rid of the sine, so that way I can solve for what angle I'm at.
No, I understand the crossing out. I don't understand where the -1 went on the left side. There's nowhere.
That's literally how it is. I mean,
It just disappears.
it's like what happens to the square root? Like what happened to the square if I square root?
But it's a little different.
It's not different at all, actually. They exactly cancel out.
But then why does it stay on the other
Huh?
side?
Yeah, this is the notes.
So like, what about the other side then?
What about,
The -1's on the other side. It's just not on the left. So like,
it is on the, oh, because on the left side it canceled out? Are you guys confused as well? Like, no? Okay, do you want to try explaining it? Do you want to try explaining it?
They're not confused.
Yeah.
They're not gonna understand that.
I just want to know if you guys are confused as well. To find the angle, you do sine to -1 on both sides. When you do that, sine inverse and sine cancel each other out. It's like a square root and a square cancel out. So if we're trying to find the angle, so if I plug this into my calculator, I think an example would be helpful. I go sine inverse, And then I'm going to put 1/2, so 1 divided by 2. Oops, I forgot the parentheses. Hold on. Sine inverse of 0.5, because that's a half, and it gives me 30 degrees. So sine inverse, cosine inverse, tan inverse, the inverse gives me angles. If I'm trying to solve for an angle, I'm going to have to use an inverse. So this is equal to 30 degrees. We can try tangent. Maybe it's just a process. I'm sure it's confusing if you never saw it before. So I need to get theta by itself. I need to solve for this angle.
Yeah.
How do I do that? How do I get it by itself?
Yeah, I don't know.
You do this
Right.
and
So the only way, okay, this is wrong. You can't just divide by tan. That doesn't make sense. It's like dividing by a plus sign.
Or you multiply by
So I have to do the opposite operation. Instead of taking tan of the angle, I have to do the inverse operation. So I have to take tan inverse of both sides. So tan inverse of tangent theta is equal to tan inverse of
Aren't we
12
not
over
supposed to-
5.
What is this thing?
This is geometry. So
I don't know what I did last year.
do you sharpen your pencil? Okay. Thanks. I'm trying to like go as slow as possible. Definitely look at like Khan Academy or like your book, like chapter 12, section 1. This is what it is. It goes through, it explains it again.
But then there's nothing on the left side.
So hold on. So the tan inverse and the tan go away and it leaves me with the angle by itself.
That's actually a thing.
Yeah. And then on the right side, tan inverse of 12 over 5. So if I plug this into my calculator, let's see what I get. So tan inverse of 12 over 5. Go trig.
What
Tan
do you do with
inverse
that weird circle
12
line in it?
divided by 5. That's angle, that's theta.
When did this come into play? Like,
I assumed you guys, like, since geometry is all about angles, I assumed you had saw theta before.
never.
What did you use for an angle? No, that's definitely, I'll
should
definitely.
we go like should we do like this or something maybe this is like
Yeah, like you could ask
like
the
should we do
class.
like that thing?
Okay, so theta means angle. It's just the variable for an angle. Now you know. So the degree is 67.4. Let's see what it wants us to round to. Round each answer to the nearest angle. So since we're at 67.38, I'm going to round it to 67 degrees. Tan inverse, cosine inverse, sine inverse, they just give you the angle. So about part C, how would I do this one?
You go cosine with that weird thing.
Cosine inverse.
And then you do -1 in parentheses.
Nope, it literally is cosine inverse. It's not cosine to -1. This whole thing is cosine inverse. That's what it means. Cosine inverse. You don't say cosine -1. Cosine inverse. So I'm telling you how to say it, that way you don't screw up. Alright, cosine inverse cancel out. Theta is equal to cosine inverse of 0.5824. So what do you get when you plug this in?
Some number.
Yep. Not for this one. Not for this week.
But is it gonna be chocolate?
Probably. I don't know. I haven't quite looked.
54.3805.
54 degrees. Perfect. Alright, let's go to the next side. Alright, so use trig functions to find the measure of theta, the angle, round to nearest degree if necessary. Okay, so I'm wanting to solve 54 degrees. So I'm wanting to solve for this angle. I need to label the sides. What sides do I have? I have the opposite, and I have the hypotenuse. So from SOHCAHTOA, I know sine is opposite over hypotenuse. So I'm going to do sine of theta. That just stands for my angle. It's like a 0 with a line through it. It's a Greek symbol. It stands for angle. Sine of theta is equal to opposite 14 over hypotenuse 16. How would I get my angle by itself? How do I solve for the angle?
Multiply by 16.
Divide
No. How do I get the angle by itself? How do I get rid of sine?
Multiply.
I take
Oh.
sine inverse of both sides.
How do you know when you need to do that?
When I'm solving for the angle, I do sine inverse. When I'm solving for an angle, I do the inverse. When this is the unknown, when I'm solving for the angle, that's when I do the inverse.
Okay, and when you're just signing for sine, you multiply it.
When I'm just solving for an angle, when I'm solving for a side length, I'll have to like multiply and get it by itself.
So like sine isn't a part of like that.
No, it's not. Sine is an operation. It's like multiplying, dividing. It's like you're doing something to a number. Sine is like it's an operation. You're doing something to the angle. Sine of 14 over 16. That's going to be equal to 61 degrees. So I showed you how to plug this in already. We go to the next one. Have my adjacent, have my hypotenuse. So if we do SOHCAHTOA, I can say cosine of theta, the angle, is equal to adjacent 5 over hypotenuse 12. So to solve for the angle, I will take cosine inverse on both sides. So I'll do cosine inverse on both sides. So the angle is going to be cosine inverse of 5 over 12. Cosine inverse of 5 over 12. Trig, cosine inverse 5 divided by 12 equals 65 degrees, because I'm rounding to the nearest degree. Right? You can move over. Is that better? Okay. Alright, so we learned how to solve for a side. We've learned how to solve for an angle. We can put it together. We can talk about uses. So angle of elevation, depression. An angle of elevation is formed by the horizontal line and an observer's line of sight to an object above. So for instance, if you're looking out, so put your hand straight out in front of you. Waiting. Yep, one of your hands. And then like look at the top corner where the ceiling and the wall meet up above you. So you see like compared to the horizontal, it's up at an angle. So literally it's the angle from straight in front of you, the horizontal line of sight to something you're looking at above. It's like when you are walking through town and then you like look up to see a building, that's your angle of elevation. Right. So an angle of elevation is formed by a horizontal line and an observer's line of sight to an object above. An angle of depression is the angle formed by a horizontal line and an observer's line of sight to an object below. Angles of elevation and depression are blank because they are the alternate interior angles of parallel lines. What do you guys think? What goes there? So, thinking back to your geometry knowledge. Do you know? In geometry or in this class?
Math.
Cool. Because a lot of this is from geometry. Like some of these figures I literally took from your notes last year. Like your class last year I went through.
I don't think we did.
Yeah.
You learned about angles of elevation depression. Literally, it's because here's a line, here's another line. If they are parallel, what is true? about the angle about the line that crosses them. A transverse line.
No, all we learned was if it's dotted or straight, and like if it's like vertical.
Angles of elevation depression are congruent. Guarantee the angle right here is equal to the angle right here. They're congruent because they're alternate interior angles of parallel lines. We're on the top of page 8 with your notes. Congruent. All right, example 10. A group of hikers are on a camping trip to the top of a 1,500-foot mountain. When the hikers look down at an angle of depression 36 degrees, they can see a campsite in the distance. What is the horizontal distance between the campsite and the group's nearest foot? So what we just talked about was the fact that, like, here's one parallel line, here's another parallel line. I have a transversal that cuts them, meaning I have a line that cuts them both. This means that the angle 36 here is going to be the same as the angle here. Between the ground. No, do you see what I mean? This is 36 degrees as well. It's kind of hard to see. So the angle right there is 36 degrees. So if I redraw my triangle, this is 36 degrees, this is x, my height is 1,500 feet. I'm solving for x. How do I do this? Well, I could, except I don't have the hypotenuse length either. What about SOHCAHTOA? Which one could I use?
SOHCAHTOA. I don't even know. Okay, I understand.
So let's label. Let's label our sides. X is which side?
I'm just trying to understand.
It's my adjacent side. X is the adjacent side to the angle. What are you doing?
I'm just trying to understand this. Like, I don't understand what side.
Step 1, putting on your phone. 1,500 foot is the opposite side.
How do you know that?
Yeah, I don't know how to.
I understand the SOHCAHTOA.
I don't even know how to put, like.
That's the first.
So the adjacent side.
How do you know if it's adjacent?
The adjacent side, hey, check it out. It's literally one of the legs of the angle.
Adjacent to what?
The angle. Look, the angle 36 degrees. This is the side that touches the angle. Which is the side that, like, 36 degrees is facing?
But that touches, the other side touches it too.
What other side? This is the hypotenuse.
How do you know that's the hypotenuse?
Because it's the longer one.
The longest one always
is the hypotenuse.
And then how do you know the difference between an angle and the op, or the A and the O?
Okay.
Because whichever one is touching the angle versus whatever one's on the complete opposite side. Notice that this side length right here is not touching 36 degrees at all. It's the opposite side. Yes, David. Yep.
Can you review a little bit before the quiz?
Can you do what?
Can you review for at least like 2 minutes?
Sure. Just be on time. Like, it's right before lunch.
So 4th period, okay. So, same shit, right? So, how long do we need for the quiz? How long?
That's the only thing that I'm planning on for tomorrow. It's just this quiz.
So, how long is it? Like 25 minutes, that's it? It says, like, on the paper, it usually says like 25, 30, whatever.
Yeah,
So, can we review like 15 minutes?
that's fine.
Wait, so how many questions?
Right, so I have a like review quiz practice for you. I have a practice quiz for you. What? So I'm gonna finish like going over this with you before I go over the practice quiz. We're going to page 10. Exactly.
That'll be like a good 30 minutes.
So if I'm wanting to solve for this side length, I see that's my adjacent side. Because it's literally, this is touching part of the 36 degree angle. Versus the opposite side is not touching my 36 degree angle at all. So which trig function can I use? So if I use tangent, tangent is opposite over adjacent. Hey, check it out, I have both. Tangent of 36 degrees is equal to opposite, which is 1,500, over adjacent, here's x. I want to get x by itself.
Times by x. So it's x tan 36 degrees equals 1500. And then don't you divide by tan 36 degrees?
Yes.
And then you plug x equals 1500 over tan 36 into your calculator. So how does that?
So x is equal to 1500 divided by tan 36. That gives me the adjacent side length.
So you just do 1536.
1500 divided by tan 36. Yeah. I'm sorry. Because you guys can like move. You don't just sit there. Are you in a bathroom? Yeah. Do you know how many bathroom passes you've used? Are you gonna go or not? Okay. Let's see. Just
I have one left.
today, last class, one before. That doesn't include. No, that's a lot.
So Brian, I got 2,064.
Okay, well that's 8.
8 bathroom passes, and you swipe off like 4 points of bathroom pass.
No, not 4.
How many do I have?
I have 2. I've used
Alright,
2.
let's-
I have 1 left.
Yeah, I don't really have bathroom passes on, but I don't think that's
Yeah, so it hurts.
Wait,
balances out.
Being tardy loses half your participation points because then you ask questions that literally I already answered. Like you asked, oh, am I going through the whole packet? Nope. That's one of the first things I said today was we're going to page 10 and then that's it.
And you take points off of it?
If you're not here, you can't participate. All right, x equals.
Trying.
I know. This is improvement. This is good. We're really focusing now.
So,
X
Mark,
equals-
can you help me figure out how to use the calculator for this stuff? 'Cause, like,
Yeah, so I'll go through this. All right, so x equals 1500 divided by tan 36. So I come here. 1500 divide by. And how do I do tan? How do I find it? Push the trig button. Go over to where it says tan. Alright, push enter. Here it pops up. And what angle am I trying to do? 36. Make sure it's in degree mode. Check out the top right hand corner. It says degree. Enter. Hey, look, 2064.57. I'm supposed to round to what? The nearest one, the nearest tenth, the nearest foot? 2065 feet. Alright. Nearest foot, 2065. Alright. 2065 feet. Check it out. Alright. Solving a triangle. Recall a triangle has 3 sides and 3 angles. To solve a triangle, we're given 3 of the 6 quantities. So there's 3 angles, 3 sides, that's 6 things. If I've given you 3 of them, that's enough to solve the other 3. To solve, okay, trig functions and inverse can be used to solve a right triangle. Solve each triangle, round each side length to nearest tenth, angle measurements to the nearest degree. Okay, so I'm going to do this first one. So there's 3 things I need to find. Alright, so I need to find this angle A. I need to find the measure of angle A. I need to find the measure of angle C. And then I need to find the side length of C, the C side. Which do you want to solve for first? Gabby, what one do you want to solve for first? Huh. Alright, so if I want to solve for angle A, according to angle A, so I'm going to write this in a different color now that we're going to use it. So measure of angle A, this is what I'm looking for. So according to angle A, I have the hypotenuse, and I have, what is this? 20 is my, which side is it? It's going to be my hypotenuse, adjacent, opposite. 20 is my opposite. How do you know? Because check it out. 20 is not touching any part of my angle A. It's not either one of the 2 sides that make up the angle. So if I'm wanting to solve for the angle, I have the opposite hypotenuse. Which one should I use? Sine, cosine, tangent?
Sine.
Sine. Sine of your angle is equal to opposite over hypotenuse. So sine of angle A is going to equal opposite 20 over hypotenuse 37. How do I actually solve for the angle?
Do you multiply by 37?
How do you know what it's?
So sine is opposite of hypotenuse. I have the opposite side and I have the hypotenuse side.
Oh, that's how you know. But I thought, so you're not getting angle. You're not trying to
I
find
am
the
trying to
number
find
for
the angle. I am. That's
A,
exactly what I'm
then
trying
why
to
did
do.
you write A in?
What do I write? What?
You wrote sine A, but you said let's find the angle for A.
Yeah, this is the angle.
So
A.
it's just sine A is the angle for A.
So sine of A, like sine is like a ratio. You're figuring out the ratio for a certain angle, the ratio of sides. So I need to get the angle by itself. Sine of this angle is equal to 12 or 20 over 37, but that's not what the angle is equal to. To solve to get the angle by itself, to get A by itself, I have to do sine inverse of both sides. To solve for angles, you use the inverse. So sine inverse of sine of A is equal to sine inverse. I'm just taking sine inverse of both sides. On the left side, the sine and sine inverse go away, so your angle A is just going to be sine inverse of 20 over 37.
So whenever it's A,
Whenever
it's
you're
like
looking
a
for your
variable,
angle.
or it's like that circle,
When you're looking for your angle.
for an angle, or it's like a letter or whatever.
When you're looking for your angle, so sine of some angle, cosine of some angle. Whenever this is the area you're solving for, you're going to do inverse. Versus if I was solving for a side length, that would be different. Because then I'd be solving for something over here. Alright, so what is sine inverse of 20 over 37?
32.7.
32.7 degrees. Oh wait, are we supposed to do the nearest angle? Yeah, nearest angle says 33. Okay, so I'm going to come back up here. I know this angle now. I know it is 33 degrees. What do you want to solve for next?
To plug it back.
Well, because I need to solve for the other two quantities. Because I know the little box angle, that's 90 degrees. The one at the box in the corner, it's a right angle. How do I solve for angle C? Let's solve for that one next. How do I solve for angle C?
Oh, I thought you were done.
Oh, it's the adjacent over.
Yeah, I could do cosine, or all three angles in a triangle add up to 180 degrees. So 180 degrees is going to equal 90, because this is a 90-degree angle, plus 33 degrees, plus
So
the
it's
measure of angle
77.
C.
So it's 77.
Not quite. So 180 degrees is equal to 123 degrees, plus
Oh,
Angle
I did my
C.
math so wrong. Wow.
plus angle C. So I'm trying to show this as an angle. Subtract 123 from both sides. You get 57 degrees is angle C. So this is 57 degrees. So we used our geometry knowledge that the angles in a triangle add up to 180 degrees.
And then you need to find C too.
Then I have to find the length of side C. So there's multiple ways we could do it.
Can you just add up like 90 to 33, 123, and whatever that is 180?
Yeah, that's exactly what we did.
Why is it so complicated?
I don't know.
Why can't it just be that? Why can't it just be like, okay, 90 to 33 is 123, and it's 57 left until it's 180, and that's what it equals?
That is exactly what it equals.
But why? No, it doesn't look like that though. It's so much more complicated.
I'm showing every step of my calculation.
Oh, I don't need that.
Okay.
Couldn't you just see that? Or like, there was that like square thing before?
Wait.
So you'd have to know like 33 plus angle C is equal to 90. Yeah.
So you have to find A, and then once you find A,
We had to
it
find-
gives you C, because
Yep.
you just add it up and subtract by 180.
Yep.
So then how do you find C?
The length. So we found the angle C. Now we need to find the length for side C. So we could use SOHCAHTOA, or we could use Pythagorean. We could use Pythagorean theorem. I know 20 squared plus C squared is equal to 37 squared. This is
Oh,
leg leg, hypotenuse. Leg, hypotenuse. So 400 plus c squared equals 1,369.
And then subtract 400.
Subtract 400. Square root both sides.
I told you like 46 squared and you doing that.
Ish.
Maybe not right now.
How many more pages do we have?
1329.
Just a second.
Wait.
Really just be around the linear.
Wait. Round to nearest tenth. What'd you say it was?
I don't know.
So,
Isn't it just 31?
no, that'd be to the nearest 1. Or to the nearest tenth. Tenth is one place after the decimal.
Why for the other one for 20 over 39?
Because that's the angle. We want to nearest degree versus nearest tenth for sides. All right. So this is, right, we could do B, but this is exactly where I wanted to stop, more or less, because the stuff below is review. This is just going over the exact same thing we just went through. So let's go over the second triangle. Okay, so things I need to solve for. I need to solve for angle, the side S, the side R, and whatever angle this is right here. Which do you want to solve for first? What about the angle? Let's solve for this angle first. Look, I have a 23 degree and I have a 90 degree.
That's 113.
So that's
113 minus that, so that's 120 minus 67.
180 minus 113,
67.
67. So this is 67 degrees. Yep.
That's it, we're done.
Okay, well, I need to solve for the two side lengths.
So, R.
Go for R? Okay. So how do you want to solve for it? Which angle?
Which what?
Which angle? Well, 90 doesn't...
That was 67 and 23. And then, yeah. Whatever, 67.
Because you have a calculator. Okay, so we're going to use 67 degrees. Okay, so according to 67 degrees, R is my adjacent, and 35 is my opposite.
Could I have done it? Oh, and if I use 23, it would be totally different.
Yep. Do you want to use 23 instead?
No, it's fine, David. Take that. It's fine.
Well, whatever. This is not.
Let's use 23. 35 is now my adjacent, and R is my opposite. So if I use SOHCAHTOA, let's use tangent. Tangent of 23 degrees is equal to opposite, which is R, over adjacent, 35. How do I get 35 by itself? Did I ask how to get 35? How do I get R by itself?
Oh.
Multiply by 35. So that makes it a little easier. R is equal to 35 times tangent 23 degrees. What will this be?
35 tan 23 degrees R equals R.
Yeah.
And then you plug that in.
Plug into your calculator.
35 times tan.
23, yeah. 35 times,
Tan.
yep, click trig, go over to tan.
So 23.
23, just 23 degrees, and it gives me 14.85. So I want it rounded to nearest tenth, 14.9. So this is 14.9. Round to the nearest tenth. It says in the directions,
How do we write our answers
lengths
for
to the
these?
nearest tenth.
So do you only want the C for the answer? Is that like what you're asking?
So what do you mean C?
Like you only want like
I'm wanting the angle here. I'm wanting the side length. I'm wanting.
So R.
So literally what you would write is angle T equals 67 degrees. R equals 14.9. Like you box it. S equals, and then we haven't solved for it yet. How would I solve for side length S? How would I solve for this side length S?
Let's use the Pythagorean theorem.
Heck yeah, let's use Pythagorean theorem. So I have 35 squared plus 14.9 squared equals c squared. 35 squared plus 14 squared. Alright, 35 squared plus 14.9 squared equals this number, but this is c squared. How do I actually find what c would be equal to? I square root it, so I can raise it to the 0.5 power. That's the same thing as square root. So 38.0. 38.0. So s is equal to 38.0. Well, once it to the nearest tenth, I rounded, so I want it 38.0 because that's the nearest tenth.
So you're going to spread it off.
Yeah, because it says to the nearest tenth.
Okay, so
Cool.
practice the quiz.
Yeah, I'll give you guys a practice quiz.
I'm
Alright.
not gonna go over it.
The last 2 pages are review.
Okay.
Alright, so come grab one.
When is this packet due for homework?
The homework is due tomorrow.
Shoot me between the eyes.
Can you pass them out?
Yeah, just a second. Yeah. There's 2 of them.
You're just going to pass them out.
I'll take that one.
It's just weird because I just did this and I just looked at the homework and I like blanked.